Hello again. In this video, I'll be talking about the LAB4, what we are going to do in LAB4 and what is expected from you and all that. But before that, at this point, you must have watched the tutorial video. If you haven't watched, you have to go back and watch it because I will not be explaining a lot on the Verilog part. I'll just talk about what is expected from you and what you will be submitting and what is actually being done in LAB4. So I advise you to watch the tutorial video. Okay, let's continue. We have done this in LAB3. This time we want to do it in FPGA. We want to do the same circuit, similar circuit. Here we just can display only from 0 to 3. In this lab, we're going to display from 0 to 9. And so that means the inputs A and B has to be 4. A, B, C, D. They have to be 4-bit inputs. So this is one example. This is exactly same thing. We have done it here. Exactly same thing done in Verilog will look something like this. Exactly same thing. Okay. So A and B are inside switch. These are the ports that I have, and switch is 2-bit, as you can see, 0-bit and 1-bit. So that means we have switch is size 2. It's size 2, just like seen here. And the output is 7 segment, which is 8-bit. This is 8-bit. This cross line here shown to show that it's 8-bit. Here it's 2 bits. And AN is just used to select one of the 7 segments. So in our FPGA, we have 4 7 segments, so we have to activate one of them at a time. So we are selecting this one. That's why we are giving this value. 0 means activated, 1 means deactivated. So by just setting AN to this value, we are activating this 7 segment, but this will be shown in the FPGA hardware by itself. But now, since we are doing simulation, this doesn't matter much, but let's still set it to 0 and the rest 1. And so this part we can see case, in case. This case is used as if else, just like if else. Okay, here switch is the controlling element here. So when switch is 0, seg is set into this. That means when switch is 0 0, this is 0, this is 0 1, this is 1 0, this is 1 1. Okay, so this will be displayed on the 7 segment. So what you see from here is only G. This is G. Okay, only G is 1, which is deactivated. The rest are activated. That means only G, which is this middle part, is deactivated. The rest are on. That means there's light. It looks 0. Okay, same thing by just same concept. A, B, C, D, and this last one is point. So this is G. So in that consideration, you will do this is done. So from you, what is expected from you is actually you will change this one into 4 bits. So this one will be 3 3 2 1 0. So this one is set to 3, and you will continue here from 0 to 9. So you have to fill in here. So we have provided you a code such like this. You just fill into a place where it says fill in here. Okay, so this is an example. So to see if our design is working right or not, we have to test it. For testing it, our test bench Verilog, which is provided by us, we are giving you. You don't need to change the test bench file. Only thing you should change is this file, 7seg.file. We are giving you 2 files. You change 7seg.v file. Don't change tb test bench file. So test bench will provide values here, which will set switch value to 0 to 1 to 3 to 4 to 5 to 6 and to 9, and you will see values here. in 7 segment, 8-bit values. Okay, this is 8-bit, and we'll see the output on the 7 segment part, which is seg. Okay, now let's go to the code that we have provided. We have provided this file, which is 7seg.v file, and in that file you can see switch ports up here, you can see switches here, and their input, and the number of size is 4-bit switch and 7seg 8-bit, and because we are putting them inside always at star block, that's why we are putting reg here. An is on the right side, so it's reg. Same thing, seg is also on the right side, that's why it's reg. Okay, so this part is completed. All the things that you need to write is here. You will continue from here. You will say for and continue like that. Okay, write your code here, and then just like I showed you from the tutorial, you have to use this test bench file. The test bench file, what is doing? Test bench file, it's providing the 7seg file. It's providing switch value and taking outputs. An and seg are outputs. Okay, so switch, we are giving value to switch 0. That means 0 0 because switch is 4-bit. 0 0 it means. Then we have switch is set into 1 after 50 nanosecond. That means 0 0 1, and then you go like that. And then the seg value will be changing at the output side. So after running this, just like I showed you from the tutorial video, you have to run the test bench file. When you run it, you'll see something like this. You will see this one. You will see something like this. Okay, seg will show you something like this. Okay, this ones. So when switch is, for example, 4, I will see this one. This will actually, it is 4. It is 4 in 7 segments. So if you connect these pins into 7 segments, you will see 4 in the 7 segment. Okay, so this is how it is. So what is expected from you is to add the files, which are these files. You will add these files, this one and this one, into your file, into your project. After that, simulate it. After filling this the missing part in 7seg.v file, and then run it. After you run it, after you run the simulation, you'll take a picture of this showing exactly same thing. You'll put the screen, you'll put the ID in your on your screen and take a photo of that, and then you will have to upload the 7seg file, the file that you modified, 7seg.v file. You have to upload it into LMS. So that's what's expected from you.